is equal to rho L by A, where rho is the resistivity of the material, L is the length of the resistance, and A is the area of cross section. Now, you see the uniform metal wire has length L and it is having 10 ohms. So here if you see, the length is L and the resistance is 10 ohms. Now this wire is stretched to a length of 2L. So now what happens when the wire is stretched to a length of 2L? You see, the volume of the material has to remain constant. So let us say the area was A. Now the volume initially was L into A. Now let us say the area here is A dash. So therefore the volume is going to be 2L into A dash. So both the volume has to be the same, since the same material is stretched. So therefore we equate it. So this is equal to L into A. Gone. So simply A dash becomes A upon 2. So the area of cross section has reduced by has reduced to A by 2. Now what is the resistance of this? So in the first case, if you see, the resistance was 10 ohm, which was equal to rho into L upon A. Now here the new resistance is equal to rho into, now what is the length? Length is 2L. So 2L divided by, the area of cross section is A by 2 divided by A upon 2, which is equal to rho into 4L upon A, which is basically 4 into rho L by A. Now rho L by A is 10 ohms, so therefore this is 40 ohms. 40 ohms. So therefore the new resistance of the stretched material is 40 ohms. Now this 40 ohm is, okay, this 40 ohm is it is bent in the form of a circle. So this entire circle is of 40 ohms. Okay, fine. Now they want us to find out the equivalent resistance across any arbitrary diameter. So we have taken this as the diameter. Okay. Now across this we have to find the resistance. So you see the above part, the resistance is going to be 20 ohm, and the below also the resistance is going to be 20 ohm, since the 40 ohm resistance is now divided. So 20 ohm and 20 ohm, and now both of them, they are in parallel. So therefore 1 by R is equal to 1 upon 20 plus 1 upon 20, which is 2 upon 20, which is 1 upon 10. So therefore the resistance is going to be 10 ohm. Okay, so therefore the answer is going to be A. So just summarize what we did. So first we understood that resistance equals rho L by A. Now on stretching it, the length increases and the area of cross section also changes. We found out what is the new area of cross section, and the new length is given. Based upon that, we found out the new resistance of the material. So that came out to be 40 ohms. Now when it is bent in the form of a circle and the two end points of the diameter are connected, so connected means like we have to find the equivalent resistance across it. So we did an equivalent circuit diagram. So this is 20 ohms here, 20 ohms here, and when we find the equivalent resistance, it comes out to be 10 ohm, because both of them, they become in parallel. So therefore the answer is 10. Thank you.